solving rational equations, just as a warm-up, because you'll never be asked to do anything quite this easy. If we have 3x over 5 equals a half, but the idea we're going to explore here is how we're going to solve everything. And the idea is, let's get rid of the denominator. How do we do that? We multiply everything by the lowest common denominator, which in this case is 10. So this is how that would look. 10 over 1 times 3x over 5 is equal to 10 over 1 times 1 over 2. Okay, 5 goes into 10 twice, 2 goes into 10 5 times, 6x is equal to 5, and x will be 5/6. No non-permissible values, right, because there are no variables in the denominator here. And as a matter of fact, actually sort of the easy way to do this, right, I mean, this is what's going on, that we're multiplying everything by 10, but we can just sort of think about it in our heads. I'm going to multiply by 10, so the 3x is going to end up being multiplied by 2. As a matter of fact, I'm not going to think of it as 10, I'm going to think of it as 5 times 2, and the 5 on the bottom is going to cancel. And I multiply this by 5 times 2, and the 2 on the bottom cancels, giving me the 6x is equal to 5, and so on. And as I said, nothing that easy for you, so let's pick one up that actually has some variables in the denominator. Okay, how about this? 5, this nice rational expression, 5 over x minus 1 is equal to negative 2 over x plus 2. Now, if we see rational expressions, we should be thinking factoring, but there is nothing to factor here, so we need to think non-permissible values. So x cannot be 1 or negative 2. Negative 2 comma 1. This is especially important now because when we solve, if we get a solution of negative 2 or positive 1, then we would say there is no solution to this. Okay, next step. So once you've got everything factored, you then want to multiply by the lowest common denominator, which will be x minus 1 times x plus 2. And how will that all simplify? So the 5 has an x minus 1 on the bottom. That will cancel, and we'll just be multiplying the 5 by what it doesn't have, which is the x plus 2. Very similar to when we added, right? It's like, what's in the denominator? Well, we've got an x plus 2 here, so we're just going to multiply by x minus 1, giving me 5x plus 10 is negative 2x plus 2. This comes down to a linear equation, which we solved. Let's add this, giving me 7x. I always like my x's on the left-hand side, and that's negative 8. And x will be negative 8 over 7. One nice solution. It is a permissible value, right? It will not cause these to be 0. And if you want to check it, certainly you may go in and check and see that you have in fact found the solution. Okay, let's step it up a notch. Okay, how about this one? Nothing to factor, right? The denominators are all in simplified factored form. So we may state non-permissible values. X cannot be 0 or negative 1. And we need to keep that in mind because if we solve this and end up with a solution that is 0 or negative 1, then we need to reject that. Okay, we're going to go through, we're going to multiply by the lowest common denominator, which we can see will be 2x and x plus 1. And this just has a denominator of 1 if you like. It's not written, but we can think of it. Okay, what does this have? It's got a 2x. What's it missing? It's missing an x plus 1. Minus 2x. What's it missing? It's missing a 2x. And what's this missing? Both a 2x and an x plus 1. Now, we're not adding or subtracting, right? We're solving. We're solving an equation. If I were adding or subtracting, this equals, none of this would be here, and we would have to keep the denominator. Since we're solving, we can multiply everything by the denominator, and that's why there is no denominator here, right? But still sort of the same idea as adding or subtracting, but we do not need the denominator because we've multiplied it out. All right, simplifying. 3x plus 3 minus 4x squared equals, and let's take some care to multiply this out properly. So I'm going to do the monomial times the binomial first. So 2x squared plus 2x. Over here, let's just write this in order. Negative 4x squared plus 3x plus 3 equals negative 4x squared minus 4x. Let's move these both over. The 4x squareds really are just going to cancel, right? We're just adding 4x squared to both sides. Let's add 4x to both sides, giving me 7x plus 3 equals 0. 7x is negative 3, and x is negative 3/7. Check that against the non-permissible values. It's permissible. And so x is negative 3/7. And this, of course, could be verified if you like. Okay, let's get to something more likely what we're going to see. So we have to do some factoring here. So that's the first step, right? Generally, in anything to do with rational expressions is factor if you can. 4 over x minus 3. Once we have a rational expression in factored form, then we state the non-permissible values. So x cannot be 0, 0, 3, 3. So x cannot be 0 or 3. That tells us we have some common factors here. So the lowest common denominator is x times x minus 3, and I'm going to multiply every term by that. Well, the 12 already has the x and the x minus 3, so it stays alone. The 6 has an x on the bottom, so it will be multiplied by x minus 3, and the 4 has an x minus 3, so it gets multiplied by x. Okay, simplifying 12 minus 6x plus 18 is 4x. Normally I'd move this over, so negative 6x plus 4x is 10x. So I'm moving it to the right side, but writing it on the left side. And the left side is 30, and I'm moving that to the right side because I like my x's on the left. So, had we done it and gotten 30 is equal to 10x, that certainly allows us to rewrite this as 10x equals 30, and x is equal to 3. But wait, 3 is a non-permissible value. We can't put a 3 in. If we try and put a 3 in, we'll get a 0, and 12 divided by 0 is undefined, or here we'll get a 0, and 4 divided by 0 is undefined. So we must say there is no solution. Okay, there is no value of x that will make this expression true. And the reason we get the 3 as a solution is because we've multiplied through by the lowest common denominator. That's removed any denominators, and it allows one of the non-permissible values to become a solution to the new equation, which is kind of the same, but not exactly, right? It will evaluate the same for every value of x as long as x is not 0 or 3. I mean, certainly we can evaluate this when x is 3. We get 12 is equal to 12, which is true, but not helpful in this particular case. Okay, so what are your steps? Factor. From the factored form, state your non-permissible values. Multiply through by the lowest common denominator. Simplify. Solve. Check. Okay, we're going to do one more. Last example. 3x over x plus 2 minus 5 over x minus 4 equals 4x squared minus 15x minus 18 all over x squared minus 2x minus 8. Wow. Okay, first step still the same. The idea is we want to factor. Now there's nothing to factor here, so we just write it out. I'm not worried about factoring the top at this point. I would like to factor the bottom because I need non-permissible values. So we're going to leave this because, we'll see what happens. And I'm going to guess that the factorization of this is really just these two factors here. So x plus 2, x minus 4, which I said I guessed. So x squared minus 4x plus 2x is minus 2x minus 8. Good guess. Not really. Non-permissible values, negative 2, positive 4, negative 2, positive 4, negative 2, positive 4. Okay, let's go through. We're going to multiply by the lowest common denominator. So it'll be 3x times x minus 4, right? The x plus 2's will cancel. What is this missing? Minus 5. It's already over an x minus 4. We're going to multiply by x plus 2. This is over both, so it doesn't have to be multiplied by anything. Okay, 3x squared minus 12x minus 5x minus 10. 4x squared minus 15x minus 18. Now, I'm not going to write it, but I'm going to think of this as minus 17x. He says, writing it, but that's my thinking. I want to move the 3x squared over here because I'm going to subtract. Okay, so 4x squared minus 3x squared. Add 17x to both sides, plus 2x. Add 10 to both sides, minus, erase, minus 8. And that's equal to, since all of this was moved, that's equal to 0. Okay, now how do we solve these guys? Well, remember, we factor. So does this factor x, two numbers multiply to 8 differ by 2, larger one is positive, x squared minus 2x plus 4x is plus 2x minus 8. X is negative 4 and positive 2. And, it's kind of the opposite of negative 2 and 4. So these are good solutions. So our solution set is negative 4 and positive 2. Okay, one more time. What are your steps? Factor denominators, right? We need that for two reasons. 1, non-permissible values. 2, lowest common denominator. So factor the denominators, find the non-permissible values, multiply through by the LCD. This is the quick and easy way, right? Where you're just showing this, not showing all of the mess that goes along with it and all the cancellations. Simplify. Collect all your terms to one side. In this case, collect them to one side because this is a trinomial. If I just had an x, x's on one side, numbers on the other, solve a linear. This is a quadratic, solve by factoring, check against the non-permissible values, and we are done. For example,